Okay, I'm back, and now we want to go to the big bad boys. So these are going to be greater than 30 times the mass of the sun, and you will notice that these start out exactly the same way that the medium size and the large ones do. So at first they're going to be converting hydrogen into helium, but they run out of the hydrogen. Okay, then they convert the helium into carbon, but then they run out of the helium. They manufacture all the elements up to iron, then they collapse, then they explode as the supernova. And so you might think, well, they just end up as a neutron star, but this time they're so large that gravity overpowers the neutron degeneracy pressure that holds up these things, and it crushes it out of existence. So that physically speaking, the star no longer exists. It has no diameter, but it's still there. So it has all of its original gravity of the thing that's left over after the supernova has occurred. It still has all of that gravity to it, but physically it doesn't exist anymore. So this thing is going to be a black hole. You can't see a black hole. So where the black hole is a mathematical point which we call the singularity. That's physically where it would be, but it has no dimension. It has no size to it, but it has all the gravity. Now surrounding it is going to be the event horizon, which is going to be how far away from the singularity can light be and still escape. So we talked about escape velocity, that if something has escape velocity, it escapes the gravity of something. So the gravity of this singularity, if you got a light wave out here, it's going to have enough speed, the speed of light, in order to escape. But if you've got light that's in here, then what's going to happen is it doesn't have enough speed, and it's going to be pulled into the black hole. So the edge of a black hole is not a physical thing. It just represents the radius at which light can escape. So inside the event horizon, it looks like it's black. And so there's a picture of a black hole, and you see that blackness in the middle. So then the question is, well, what's the orange part that surrounds the black hole? So that's going to be called the accretion disk. And so in that picture there, you have this accretion disk. You have a black dot in the middle. So the black dot is going to be the event horizon for the black hole. The singularity is inside that blackness. So all of this part out here, that is gases that's going around and around the black hole. And as they get closer to the black hole, they get faster and faster. And the faster they go, the more light they produce. So that's why this is glowing right here. Now, a black hole has a magnetic field. So just like the pulsar had a magnetic field, a black hole is going to have a magnetic field. And so some of this light can be shot out this way, and it can be shot out this way. And so these are going to be X-rays. So one way of detecting a black hole is to look for X-rays. Another thing that you should know for the exam is that a black hole rips space and time. So if you recall, when we talked about general relativity, we said that if you took a bowling ball and you put it onto a bed, it would cause the bed to do this. So there's the bowling ball. It would cause the sheets to come in. Can you see that? Okay. So causes it to cave in like that. And then if you took a tennis ball and you rolled it past it, it would curve because of the curvature of the sheets. Well, in the case of the black hole, instead of space and time bending, space and time are doing this, and it actually rips a hole in space-time when that happens. And so space and time are very distorted once you get past the event horizon, and that's being shown in that picture there up top. Don't worry about what it does to space and what does it do to time and what's it like to fall into a black hole. So that's interesting stuff, but it's not going to be on the exam. All right, so we already went over this slide, and then you should have had that open all this time so that you have seen how all of this stuff evolves. And then this one is just a computer simulation that shows the evolution of a star, which you don't need to worry about. So that is it. Remember, on the exam, you get to use your 3" by 5" card. You can write anything that you want on the front and the back. So on one side, maybe you might want to have that thing. And then on the other side, you might want to have all of these different definitions written down for it. So I will see you in class for the exam, and good luck.